Hello, welcome back. In the previous segment, we proved this theorem that the set bad is a subgroup of Z star n. But there is one more open question we need to answer. Is bad a strict subgroup of Z star n? It turned out the answer is yes. And I need to prove that first in order to tell you how many elements are there in bad. All right, so let's get started with that. We need to prove bad is a strict subgroup of Z star n. How do we go about proving it? We do know, remember, that we were able to find the largest I such that x power 2i times u is not equal to 1. And I proved earlier that such an I must exist. For example, when you set x to be minus 1, which is part of Z star n, minus 1 power u is minus 1, which is not equal to 1. That means we can always find the largest I such that x power 2i times u is not equal to 1. The question now is there an element in Z star n that is not present in bad? Okay, so let's go ahead and prove that. So in order to do that, we are making use of some interesting facts from the Chinese remainder theorem. Okay, first of all, let me draw the picture again. This is the Z star n group, and we have a subgroup called bad. We proved it earlier, okay, in the previous segment. But it is not clear from this picture whether bad is equal to Z star n. Maybe bad is equal to Z star n, but that's not the case. But we have to prove that. Okay, we need to prove there exists some element here that is not present here. Okay, how do we go about and prove it? Let's select an x. Okay, and to prove that x is not part of bad. We do know a largest I exists such that x power 2 power I times u is not equal to 1. Such an I must exist. We proved it earlier. So what does it mean by not equal to 1? It means it could be minus 1 or it could be anything else. Okay. For a moment, let's assume this value is not equal to minus 1. Okay. In that case, we are done, because in that case, x cannot belong to bad. Remember the definition of bad? Bad contains those elements for which x power 2i times u must be equal to either plus 1 or minus 1. If it is not equal to 1 and not equal to minus 1, it cannot belong to bad. Okay, that's the definition of bad. But on the other hand, what happens if it is equal to minus 1? All right, now we will apply the Chinese remainder theorem. Remember, the Chinese remainder theorem allows us to map elements from Z star n to Zp and Zq star. Okay. The P and Q are prime factors of n, which we don't know, but the Chinese remainder theorem is basically mapping an element in Z star n to Z star P Q pair. Okay, this is computed in mod n. Okay, the x power 2 times I is equal to minus 1. This becomes x. Let's assume x mapped to the pair xp xq. When we apply Chinese remainder theorem, any element x from Z star n gets mapped into x mod p, x mod q. Okay, power 2 power I times u. What is minus 1? When you map it to zp zq, it becomes minus 1 minus 1. That's something we talked about earlier. Okay, this implies that xp power 2 power I times u to be minus 1. And the xq power 2 power I times u is also minus 1. But let's only worry about this for now. Okay. And I'm going to now select an element. What if I select the element that corresponds to this tuple? I'm going to select this tuple xp comma 1, which is part of this pair, definitely. And I'm going to now show to you that if I take xp comma 1 and raise it to 2 power I times u. Now I take xp comma 1 and raise it to power I comma 2 power I times u, okay, which is clearly minus 1 comma 1 when we map it back to Z star n is different from plus 1 or minus 1. Plus 1 means both have to be 1 1. Minus 1 means both have to be minus minus, but it's different here. That means the element xp comma 1, when we map it back to Z star n, it will not be satisfying the property power of 2i times u equal to plus or minus 1. You're definitely going to find something not equal to plus or minus 1. That means our element xp comma 1, when we map it back to Z star n, is not a member of bad. Okay. Okay, what did we prove then? We proved that bad is a subgroup of Z star n in the previous segment. In this segment, we proved that bad is a strict subgroup. That means there are elements outside bad that are not part of bad, okay, which are present in Z star n, of course. Okay, let me take a step back and summarize what we proved so far. We know that a largest I exists, okay. We can always find an X in the group such that X power 2 power I times U is not equal to 1. When it's not equal to 1, it means it could be -1 or it could be something else. When it is not equal to -1, we are done, because in order for an element to be in bad, the X power 2 times I times U, I should have put times U here. In order for an element to be in bad, X power 2 power I times U must be either +1 or -1. We are choosing an X such that X power 2 power I times U is not equal to 1. And if it is also not equal to -1, then we are done. Okay, but it could be -1. So we say, okay, what happens if it is equal to -1 in this case? In that case, we take XP, XQ, because Chinese remainder theorem allows every X in Z star N to map to a pair of elements in Z star P and Z star Q. And we raise it to power I times U, which means we can apply the exponent to the individual components. And we know when a pair is -1, it gets mapped to -1, -1, just because of the Chinese remainder theorem. Because when you do -1 and take a mod P, you get a -1. You can easily prove that. We did it in one of the earlier segments. So X power 2I is equal to -1. This is clear. X power Q power 2I times U is also -1, but we don't care about that for now. Now we are selecting an element XP, 1, and we try to raise XP, 1 power 2I times U, and we've shown that that is nothing but -1, 1, which gets mapped back to Z star N to an element not having the value +1 or -1. That means this element XP, 1, when we map back to Z star N, will not be part of bad. That means we found an X outside the Z star N group. Okay, which tells us that bad is a strict subgroup of Z star N. So we accomplished the goal that bad is a strict subgroup, which means in one of the theorems I proved, size of a strict subgroup cannot be more than half of the size of the group we are working with. The size of the group that we are working with is Z star N. So bad is at most half of the size of Z star N. Okay, which is a very important theorem we need for the next segment, because we wanted to prove the probability of success that our algorithm will successfully factor N given E and D. Okay.